Question 13, evaluate the integral of 3 over x times the square root of 9x squared minus 1. If I look at the setup of this, it looks like an arcsecant setup. And if you remember, the setup for arcsecant is du over u square root of u squared minus 1. So I just need to make sure all of the parts that I need there are there. So first thing I'm going to identify is my u. Since it says u squared, this right here is my u squared, which makes my u 3x. And one thing that I'm going to check, my du then would be 3 dx, and then my a would be, whoops, this is over minus a squared. My a squared would be 1, so my a is also 1. Okay, now I have to make sure my parts are there. Notice in this formula, I have to have u sitting here. This says x. It's supposed to say 3x, so I'm going to put a 3 on the inside. Okay, and I'm not going to worry about that just for a second. Du is 3 dx. So notice 3 dx is in my problem, so I'm okay. So now I need to look at, I put an extra 3 in there and I've done nothing with it. So to undo it on the outside, that was really like me putting a 1/3 on the inside. So to undo it, I have to put a 3 on the outside. So now everything is set up according to arcsecant and I'm good to go. So I'm just going to bring down that 3, and then arcsecant is 1 over a, which would just be 1 in this case. And then arcsecant u over a, the absolute value of u over a plus c. And that would be my answer. Okay, problem 14. Evaluate the integral of 5 over the square root of 4 minus 81x squared. Okay, this looks like an arcsine problem. The formula for the arcsine is du over the square root of a squared minus u squared. So again, I want to get my problem set up. My u squared would be 81x squared, so u will be 9x. Du will be 9 dx, and a, if this is a squared right here, a would be 2. So checking my parts, du is supposed to be 9x, well I have 5x, so I would need to multiply on the inside by 9/5, which means on the outside I need to multiply by 5/9. So now I'm all set up, it's set up for an arcsine, so I'll bring down my 5/9. Arcsine is just arcsine u over a, so it will be 9x over 2. And then instead of putting plus c this time, I do have some things that I get to evaluate. So this will be the square root of 3 over 9 to 0. So I'm going to plug in the square root of 3 over 9, and then I will plug in 0 and subtract them. So I'm going to have 5/9 arcsine. 9 times the square root of 3 over 9 will just be the square root of 3 over 2. And then minus 5/9 arcsine. If I plug 0 in, 9 times 0 is 0. 0 divided by 2 is 0. Okay, now we have to go back to our unit circle, thinking where would the sign equal the square root of 3 over 2? And I'm getting out my hand right now. The sign is the numbers underneath. If I would like it to be the square root of 3 over 2, I'm going to stick in my index finger, and that would happen at pi over 3. So at pi over 3, and then I still need my 5/9 on the outside, so that part is going to be 5 pi over 27, and then minus the arcsine of 0. Where does the sign equal 0? That would just be at 0. So 5/9 times 0 is just 0. So my answer should be 5 pi over 27. Okay, problem 15. Evaluate the integral of 2 over x squared plus 4x plus 7. On this problem, since I don't have any square roots, I'm going to be going for arctan. And arctan, I know, is the integral of du over a squared plus u squared. So that's what I'm going to set it up as. I do know this is going to be a completing the square problem to get it to look like that. So here we go. I'm going to do x squared plus 4x, leave myself a blank, put the plus 7 on the outside. When I do 4 divided by 2, I'll get 2, and then 2 squared is plus 4. To undo the plus 4, I'm going to do minus 4. And then from here, this is going to factor as x plus 2 squared plus 3. So if I rewrite this whole problem, I have 2 over x plus 2 squared plus 3 dx. And so now I have it set up. Notice I have it as u squared plus a squared, but since addition is commutative, it doesn't really matter which I have first. So my u, though, is my variable. So my u will be x plus 2. My du, the derivative of x plus 2, is just 1 dx. And my a, the a squared would be 3, so a will be the square root of 3. So if I check my parts, du is supposed to be 1 dx, but I have 2 dx. So I need to multiply by 1/2 on the inside, which means I need to multiply by 2 on the outside. So I'm going to have 2 times 1 over a arc tan u over a. Okay, and then just finishing this, I'm going to just put those together. I'll have 2 over the square root of 3 arc tan x plus 2 over the square root of 3 plus c. You could also have for this one 2 square root of 3 over 3 for that part right there if you wanted to do that instead.